In this video, we are going to see about the mathematical notations. Okay, so mathematical notation is widely used in the mathematics, science, and engineering for representing the complex concepts and properties in an ambiguous and accurate way. So, for example, if we consider the Albert Edison equation, that is E is equal to mc square. Okay, so it is a quantitative representation in mathematical notation of the mass energy equivalence. Okay, so it was first introduced by Francisco Witt at the end of 16th century and largely expanded during the 17th and 18th centuries. Okay, so we will see what is the definition for the mathematical notation. So mathematical notation consists of using symbols for representing operation, then unspecified numbers, relations, and any other mathematical objects and assembling them into the expression and the formulas. Okay, it consists of symbols for representing operation, unspecified numbers, relations, and any other mathematical objects, and they are assembling them into the expression and formulas. So there is different types of mathematical notations. We will see one by one. So the first one is floor and ceiling function. So if x is a real number, okay, if x is a real number, then it means that x lies between the two integer, which is called as floor and ceiling of the x. If x is a real number, then it means that x lies between two integers, which are called the floor and ceiling of the x. So this is the symbol for the floor. Floor is called floor of x. Okay, so this is called as floor of x. It is a greatest integer that is not greater than the x. Okay, it is a greatest integer that is not greater than the x. So for example, if the x value is 3.14, okay, and we are going to find the floor. Okay, so here it is a greatest integer, but it is not greater than the x. So the floor of 3.14 is 3. So that is not greater than this x value. Okay, and ceiling of x, it is the smallest integer that is not less than the x. Okay, that is not less than the x. For example, if the ceiling of minus 8.5, okay, minus 8.5, so the value is minus 9. So it is the smallest integer that is not less than the x. And if x itself the integer, then the floor of x is equal to ceiling of x. So otherwise the floor of x plus 1 is equal to ceiling of x. The floor of x plus 1 is equal to ceiling of x. So we will see some example. Here I need to find the floor and ceiling for the given integer given values. Okay, so this is floor. So the floor of 3.13. So it is, the value is 3. So what is given in the instruction? It is the greatest integer that is not greater than the x. The next one, floor of minus 8.5. So here the value is minus 9. The value is minus 9. Then floor of 7. So it is, if it is only the integer, means it is 7. Then we will see the ceiling. So the ceiling of 3.14. Okay, ceiling of 3.14. So the value will be, it is equal to 4. So why it is equal to 4 means it is smallest integer, that is it is not less than 3.14. Okay, not less than 3.14. Then ceiling of minus 8.5. So ceiling of minus 8.5 means the value is minus 8. Okay, so the value is minus 8. Here I said wrongly, it is minus 8. So I thought it is, I said this for ceiling, right? So ceiling. So the ceiling 8.5 minus 8.5, it is equal to minus 8. then ceiling of 7, so it is only the integer, so it is equal to x, so it is 7. Okay, so the floor of 3.1 is 3, then minus the floor of minus 8.5 is minus 9, then the 7 is 7. Then for ceiling of 3.14 is 4, so it should not be smaller integer. Then minus 8.5 is minus 8, then 7 is 7. The next one is a remainder function, so that is a modular arithmetic. If k is an any integer and m is a positive integer, then k mod m. Okay, so then we can write that as a k mod m. So here the integer remainder when k is divided by the integer. It gives the integer remainder when k is divided by the m. So here we have taken the example 25 mod 7. Okay, so when we are dividing 25 by 7, so what will be 7 into 3, it is 21, so the balance is 4. So 25 mod 7 is a 4. Then 25 mod 5, so 25 divided by 5, so here the remainder is 0, right? 5 into 5, it is 25, remainder is 0, so 25 mod 5 is 0. The next one, integer value function. So if x is a real number, the integer function, so it is denoted as int of x, it will be converted into the x into the integer, and the fraction part will be removed here. Okay, so here what we are doing, we are consider only the real part and we will remove the fractional part. So here in this example, int of 3.14. So what we have to do, we have to remove the fractional parts. And what is the real part? 3. So the answer is 3. And next integer minus 8.5. So here we have to remove the fractional part, but the sign will remain same. So here the answer is minus 8. The next one, absolute value function. So we will denote the absolute value function as abs of x or mod of x. Okay, so it gives the absolute value of the x, that is it gives the positive value of the x even if x is a negative number. It will give only the positive value even if it is a negative number. So you can give absolute value of minus 5. So what will happen? So we will remove the negative part, right? So it is 15. Then abs of 7 is 7, and here it is 3.33. So this is same, we can describe like this also, above. Okay, so here the value is 15, then this is 7, and this is 3.33. The next one is a summation symbol. The symbol which is used to denote the summation is a Greek letter sigma. The symbol which is used to denote the summation is a Greek letter sigma. So for example, if let a1, a2, a3 up to an is a sequence of number, then the sum of a1 plus a2, it will be written as summation of j is equal to 1 to n, that is a of j. So here j is called as the dummy index or a dummy variable. So for example, here we have taken n factorial. Okay, so n factorial means what is the meaning? So that is 1 into 2 into 3 into 4 into 5, right? So we can write like this also, n factorial is equal to 1 into 2 into 3. So we don't know the n value, right? So n minus 1, n minus 2, n minus 1 into n. Okay, so here what is the 4 factorial? So we can write 1 into 2 into 3 into 4. So what is the value? It is 2 into 3, 6, 6 into 4, it is 24. The next one, 5 factorial. So how we can write this 5 factorial? It is 1 into 2 into 3 into 4 into 5. So it is 120. The next one is a permutation. Let we have a set of elements and a permutation of this set means the arrangement of the elements of the set in some order. Okay, arrangement of the elements in some order. So for example, we have a set of values that a, b, c. So by using this ABC, how many permutation elements we can able to write? So we can write ABC, ACB, BAC, BCA, CAB and CBA. Suppose if there is a n element, okay. So if there is a n element means, so here how many elements we have taken? N elements. It is 3. So we have to take 3 factorial. So what is 3 factorial? 1 into 2 into 3, it is 6. So we can able to write the permutations, 6 permutations. You can see here there is a 6 permutation. Suppose we have taken the element A, B, C, D. So there is 4 elements. So 4 factorial means we can write 24 permutations. Okay. The next one is a exponent. So exponent means how many times the number is multiplied by itself. Okay, how many times the number is multiplied by itself. So if m is a positive integer, then a power m. So a into a into a into a into. So we have to write m times. Okay, so for example 2 power 4. So we can write 2 into 2 into 2 into 2. So that is a 16. Then next 2 into minus 1. So what's the meaning? It is 1 divided by 2 power 4. So we can write 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2. So that is 1 divided by the 16. Okay, so this is the exponent. Then next one, logarithm. If b is a positive number, then the logarithm of any positive number x to be the base b is written as log b of log b x. Okay, it can be written as log b x. So it represents the exponent to which b should be raised to get the x. Okay, b should be raised to get the raise. So here y is equal to log bx. So what is the meaning? That is b power y is equal to x. So for example, you can see log of 2 is equal to 8. So what is the meaning? 2 power 3, it is equal to 8. Then next, log 10 of 0.001 is equal to minus 3. So that is 10 power minus 3 is equal to 001. Then log b of 1 is equal to 0 means b power 0 is equal to 1. Then log b of b is equal to 1 means it is b power 1 is equal to b. So this is the logarithm.